chemical reactions and equations. This slide presents the overview of the chapter. Learning objectives. By the end of this chapter, you will be able to give examples of chemical reactions, represent a chemical reaction in terms of a chemical equation, balance a chemical equation, list the factors that make a chemical reaction informative, interpret a balanced chemical equation, describe the types of chemical reactions with their equations and examples, explain about redox reactions with examples, give examples of oxidation in daily life, list the methods of prevention of corrosion and rancidity. Introduction. Before entering into the chapter, follow the instructions shown on the screen. Click each tab to learn more. You know that various changes in nature can be classified into either physical or chemical. Physical changes are temporary in nature. The material undergoes change in its shape, phase, size, etc., but does not undergo any change in its nature. Chemical changes are permanent in nature. The substance present before the change does not exist by the end of the change, and a new substance is formed. A chemical change always involves a chemical reaction. The chemical reaction involves in our daily life situations. For example, coal is burnt, food gets digested in our body, iron nail is exposed to humid atmosphere for a long time. We respire. Milk is converted into curd. Water is added to quicklime. Crackers are burnt. But how to know that a chemical reaction took place? Let us try to answer this question and learn more about chemical reactions. Example 1 of chemical reaction. Click each tab to learn more. Take 1 gram of quicklime, calcium oxide in a beaker. Add 10 ml of water into the beaker. Touch the beaker during the reaction. Put a red litmus paper into the beaker after the reaction. The beaker is hot. A colorless solution is produced after the reaction. The red litmus paper turns blue. The beaker is hot during the reaction because heat is produced when quicklime reacts with water. The colorless solution produced at the end of the reaction is basic in nature as the red litmus paper turns blue. Now, let us do another activity to learn about chemical reactions. Now, let us do another activity to learn about chemical reactions. Click each tab to learn more. Take 100 ml of water in a beaker. Dissolve a small quantity of sodium sulfate, Na2SO4. Take 100 ml of water in another beaker. Dissolve a small quantity of barium chloride, BaCl2. There is a change in the color of the solutions in both the beakers. Add the solutions of both the beakers. Note the changes in the colors of the solution. Sodium sulfate reacts with barium chloride to give white precipitate, barium sulfate. Sodium sulfate reacts with barium chloride to give white precipitate, barium sulfate. Now, let us do another activity to learn about chemical reactions. Click each tab to learn more. Take a 3 cm long magnesium ribbon. Use a sandpaper to rub and clean the ribbon. Hold the ribbon using a pair of tongs. Burn the ribbon using a spirit lamp or a burner. A dazzling white flame is produced when the magnesium ribbon burns in oxygen. A white powder is formed and is collected in a watch glass. Here the two reactants, magnesium in solid state and oxygen in gaseous state, combine. A single product, magnesium oxide as white powder, is formed and collected in a watch glass. Magnesium powder is formed due to the reaction between magnesium and oxygen present in the air. Now let us learn about an example of chemical decomposition reaction. Now let us do another activity to learn about chemical reactions. Click each tab to learn more. Take a few zinc granules in a conical flask. Add 5 ml of dilute hydrochloric acid into the flask. Make a note. Be careful while handling the acid. There is a change in the color of the zinc granules. Bring a burning matchstick near the mouth of the conical flask. The matchstick is put off with a pop-up sound. The beaker is warm when touched with a finger. A chemical reaction involves in both breaking and formation of bonds, a change in the state of the substance, a change in the color of the substance, release of heat energy, formation of precipitates, Liberation of a gas. After learning chemical reactions in details, let us now learn how to represent chemical reactions. Knowledge check. The description that addition of water to calcium oxide causes the formation of a colorless precipitate and release of heat, in only words, is quite long. A short description is calcium oxide plus water gives calcium hydroxide. This is a word equation. The substances which undergo the chemical change are called the reactants and are written on the left side of an arrow in the word equation. The substances which are formed after the chemical change are called the products and are written on the right side of the arrow in the word equation. Plus sign is used to add reactants and products in the word reaction. However, the shortest form of describing a chemical reaction with least number of words and symbols is called the chemical equation. A chemical equation precisely describes a chemical reaction in a compact form by using the chemical formulae of the reactants and products. The reactants and products are chemical compounds. The molecules of these compounds are made up of the atoms of individual elements. A chemical formula describes the chemical compounds in terms of the symbols of the constituent elements and subscripts to represent the number of atoms of each element in the compound. The formulae of calcium oxide, water, and the compound formed after reaction, calcium hydroxide, are shown. Replacing the words in the word equation with chemical formulae of the reactants and products, we have the chemical equation of the reaction of quicklime with water. Example: zinc metal reacts with dilute HCl to yield zinc chloride and liberates hydrogen gas. Example: sodium sulfate of reacts with barium chloride to give white precipitate barium sulfate. Chemical balancing. In a chemical reaction, an atom is the smallest particle of an element according for its mass. According to the principle of law of conservation of mass, mass can neither be created nor destroyed. That is, the mass of the reactants and the mass of the products before and after the chemical reaction should not change. It further means that the number of atoms of each element forming the reactants and the products should remain constant. In this way, application of the law of conservation of mass principle on chemical equations gives rise to the need for balancing chemical equations. Now let us learn how to balance a chemical equation. Systematic method of balancing a chemical equation. Click each tab to learn more. Step 1. Represent the reactants and products of the chemical reaction using their correct chemical formula. The unbalanced equation is shown on screen. Step 2. Tabulate the formula units in the equation. An atom, a molecule, or an ion in the chemical equation forming one unit on its own is a formula unit. Step 3. Place suitable coefficients before the formula units for comparing and balancing the number of atoms of each element on both sides. Make a note. The formula of reactants and product cannot be changed during the balancing of a chemical equation. Step 4. Check for equal number of atoms of an element on both sides of the equation using the table. make a note. The coefficients should be reduced to their smallest whole number by dividing the equation throughout with the common divisor, if the need arises. Now let us apply these steps to balance an unbalanced chemical equation. Example 1 of balancing a chemical equation. Click each tab to learn the steps in detail. Propane C3H8 is a colorless gas with no smell. It is used as cooking fuel. It combines with oxygen to form carbon dioxide, water, heat and light. The balancing of the chemical equation of this reaction involves the following steps. Step 1. Represent the reactants and products of the chemical reaction using their correct chemical formula. The unbalanced equation is shown on screen. Step 2. Tabulate the formula units in the equation. Here carbon C, hydrogen H and oxygen O are the formula units. Step 3. For placing suitable coefficients before the formula units of the unbalanced equation. Place 3 as coefficient before CO2 on the right hand side to balance the carbon atoms on both sides. By placing 4 as coefficient before H2O on the right hand side, the hydrogen atoms in the equation can be balanced. To balance the leftover oxygen formula unit, we count the total number of oxygen atoms on the right hand side and find it as 10. The balancing of oxygen atoms is completed by adding 5 as coefficient before the O2 on the left hand side. Step 4. Check for equal number of atoms of an element on both sides of the equation using the table. Let us learn to balance another chemical equation. Example 2 of balancing a chemical equation. Click each tab to learn the steps in detail. Iron oxide or rust reacts with aluminium to form iron and aluminium trioxide. The balancing of the chemical equation of this reaction involves the following steps. Step 1. Represent the reactants and products of the chemical reaction using their correct chemical formula. The unbalanced equation is shown on screen. Step 2. Tabulate the formula units in the equation. Here, the formula of the elements iron, oxygen and aluminium Fe, O, Al respectively. Step 3. For placing suitable coefficients before the formula units of the unbalanced equation. Oxygen atoms are already found to be balanced on both sides. By placing 2 as coefficient before Fe on the right hand side, the iron atoms in the equation can be balanced. To balance the leftover aluminium formula unit, place 2 before Al on the left hand side. Step 4. Check for equal number of atoms of an element on both sides of the equation using the table. Now, let us learn about the factors that make a chemical reaction more informative. Now, let us learn about the factors that make a chemical reaction more informative. Click each tab to learn more. Expressing physical state. The state of the reactants and products as matter is more informative. Some of the notations used for expressing the physical states are S for solid, L for liquid, G for gases, and AQ for aqueous solution. For example, consider the equation on screen. The above equation provides us the information that iron oxide in solid state reacted with aluminium in solid state to form iron in liquid state and aluminium trioxide in solid state. The following characters of the reactants and products provide more information about a chemical reaction through its equation. Expressing heat changes. Heat is liberated in exothermic reactions and it is absorbed in endothermic reactions. The examples of these reactions are shown on screen. Expressing the gas evolved. An upward arrow is used to denote liberation of a gas in the chemical reaction. The example is provided on the screen. Expressing precipitate formed. A downward arrow is used to denote formation of a precipitate in the chemical reaction. The example is provided on the screen. Now, let us learn about interpretation of a balanced chemical equation. Interpreting a balanced chemical equation. Consider the following chemical equation. It tells that copper in solid state reacts with oxygen gas to form solid copper oxide. The formula of the reactants copper and oxygen are Cu and O2, and that of the product copper oxide is CuO. Here 2 moles of copper reacts with 1 mole of oxygen to form 2 moles of copper oxide. Interpreting a balanced chemical equation. A balanced chemical equation describes about the reactants and products through their symbols and formulae. It gives the ratio of molecule of reactants and products that participate in a chemical reaction. When molecular masses are expressed in unified masses U, then the relative masses of reactants and products are known from the balanced equation. When the masses are expressed in grams, then the molar ratios of reactants and products are known from the equation. If gases are involved in a chemical reaction, then we can equate their masses to their volumes and calculate the volumes of the liberated gases at a given condition of temperature and pressure by using molar mass and molar volume relationship. From the balanced chemical equation, the number of molecules and atoms of different substances can be calculated by using molar mass and Avogadro's number. The relative masses of reactants and products information is given by this equation. From the equation, we get the following relationships. They are mass relationship, mass volume relationship, volume relationship, mass volume, number of molecules relationship, etc. Numerical problem. Calculate the amount of aluminum required to get 1120 kg of iron by the above reaction. Click the tab to view solution. Numerical problem. Calculate the volume, mass and number of molecules of hydrogen liberated when 230 grams of sodium reacts with excess of water at STP. Atomic masses of sodium is 23 units, oxygen is 16 units and hydrogen is 1 unit. The balanced equation for the above reaction is. Click the tab to view solution. Let us learn about the types of chemical reactions. Any chemical reaction involves formation and breakage of chemical bonds of the reactants to form the products. There are 4 types of chemical reactions. They are chemical combination. Here 2 or more reactants combine or add to form a single product. Chemical decomposition. Here a single reactant decomposes or splits into 2 or more products. Chemical displacement. In this type of reaction, one of the reactant element displaces another element from its compound reactant and takes its place. Chemical double displacement. Here, exchange of positive and negative radicals of 2 reactants take place, causing the formation of the product as a precipitate. Let us learn about each of these types of reactions in detail. We begin with an example of chemical combination reaction. Let us perform an activity to know about the chemical combination reaction. Click each tab to learn more. Take small amount of calcium oxide in a beaker. Now pour water in the beaker. Touch the beaker. Observe the changes. In this activity, we will observe that the beaker will hot during the reaction. Finally, from this activity, we learn that large amount of heat can be released during the reaction between calcium oxide and water. Here, the two reactants, calcium oxide in solid state and water in liquid state, combine and produce a compound calcium hydroxide. Such reactions are called combination reactions. Some other examples of chemical combination are shown on screen along with their respective equations. Let us perform an activity to know about the chemical decomposition reaction. Example 1 of chemical decomposition reaction. Click each tab to learn more. Take calcium carbonate or limestone in a boiling test tube. Place a delivery tube with a cork on the tube. Heat the boiling test tube using spirit lamp or burner. Put a matchstick near the open end of the delivery tube. A gas evolves from the boiling tube and passes all along the delivery tube. The gas puts off the burning matchstick at the open end of the delivery tube. A white precipitate is formed at the bottom of the boiling tube. In this reaction, the compound calcium carbonate or limestone decomposes or breaks as a reactant when heated. This is why the reaction is called thermal decomposition reaction and is endothermic in nature. Quicklime or calcium carbonate is the first product which precipitates at the bottom of the boiling tube. The gas coming out of the boiling tube, which puts off the matchstick, is carbon dioxide. Let us learn about another example of chemical decomposition reaction. Example 2 of chemical decomposition reaction. Click each tab to learn more. Take about 0.5 grams of lead nitrate in a boiling test tube. Use a clamp and stand arrangement to hold the boiling test tube. Heat the boiling test tube using a Bunsen burner. A gas evolves from the boiling tube. The color of the gas is brown. A white precipitate is formed at the bottom of the boiling tube. It is lead nitrate. In this reaction, the compound lead nitrate decomposes or breaks as a reactant when heated. This is why the reaction is called thermal decomposition reaction and is endothermic in nature. Lead oxide is the first product which precipitates at the bottom of the boiling tube. The brown color gas coming out of the boiling tube is nitrogen dioxide. It passes through the delivery tube and gets collected in the gas collecting jar. Example 3 of chemical decomposition reaction. Click each tab to learn more. Drill 2 holes at the base of a mug. Insert 2 carbon electrodes into these holes using 2 rubber stoppers. Connect the 2 electrodes to a 6-volt battery. Immerse the electrodes in water by filling the mug with the liquid. Add a few drops of dilute sulfuric acid to water. Invert 2 water-filled test tubes over the carbon electrodes. Switch on the circuit. Gas bubbles appear in both the test tubes. There is a rise in the level of water in both the tubes to different extents. Carefully remove the test tubes completely filled with gases. Bring a burning candle near the mouth of both the tubes to test the gases. The candle continues to burn in the presence of the gas coming from the first tube. The candle puts off by the gas coming from the second test tube. In this reaction, the compound water decomposes or breaks as a reactant on passing electricity. The reaction requires energy in the form of electricity and is endothermic in nature. Hydrogen is the first product which puts off the candle flame. Oxygen is the second product which allows the candle to burn. Let us learn about another example of chemical decomposition reaction. Example 4 of chemical decomposition reaction. Click each tab to learn more. Take silver bromide in a watch glass. Observe its color. Place the watch glass under sunlight for some time. The color of the chemical changes. In this reaction, the compound silver bromide decomposes or breaks as a reactant under sunlight. This reaction requires energy in the form of sunlight. This is why it is called a photochemical reaction. It is endothermic in nature. Silver is the first product in this reaction in the form of grey powder. Bromine is the second product liberated in the form of a gas. Let us perform an activity to know about the chemical displacement reaction. Example 1 of chemical displacement reaction. Click each tab to learn more. Take a conical flask. Tie a balloon to its mouth. Take a small quantity of zinc dust into the flask. Slowly add dilute hydrochloric acid into the flask. Put a cork on the flask. Gas bubbles appear from the solution. The balloon bulges out. Here the element zinc in solid state reacts with the compound dilute hydrochloric acid in aqueous state and gives aqueous zinc chloride and hydrogen gas. The element zinc, being a more active element, displaces hydrogen from its place in hydrogen chloride reactant and forms the product zinc chloride. Hence this reaction is called displacement reaction. Let us learn about another example of chemical displacement reaction. Example 2 of chemical displacement reaction. Click each tab to learn more. Clean 2 iron nails using sandpaper. Take 2 test tubes and mark them as A and B. Take 10 ml of copper sulfate solution in both the test tubes. Tie a nail with a thread and dip it into the solution of test tube A. Keep test tube A undisturbed for 20 minutes. The other nail and the test tube B are for reference. Take the nail out from the test tube A. Compare the color of the iron nails and solutions in the test tubes A and B. The nail taken from the test tube A turns brownish. The color of the copper sulfate solution fades from being blue in color initially. Here, the element iron in solid state reacts with the compound copper sulfate in aqueous state and gives aqueous iron sulfate and solid copper. The element iron, being a more active element, displaces copper from its place in copper sulfate reactant and forms the product iron sulfate. Let us learn about an example of double displacement reaction. Let us perform an activity to know about the chemical double displacement reaction. Example of double displacement. Click each tab to learn more. Take lead nitrate and add it into a test tube filled with 5 ml of distilled water. Take potassium iodide and add it into another test tube with equal amount of distilled water. Mix the solutions of the test tubes. A yellow color insoluble precipitate is formed in the test tube. The precipitate formed here is lead iodide. Here the lead ion of reactant lead nitrate combines with iodide ion of the reactant potassium iodide to form the product lead iodide as a precipitate. The other product formed in potassium nitrate in aqueous state from the remaining reactants. This double exchange of the places in the reactants forms double displacement reaction. Now let us learn about redox reactions. Knowledge check. The chemical reactions involving addition of oxygen and removal of hydrogen are called oxidation reactions. The chemical reactions involving addition of hydrogen and removal of oxygen is called reduction reactions. Interestingly, oxidation and reduction reactions occur at the same time, and such reactions are called redox reactions. Let us learn about redox reactions in detail with an example. Here, let us perform an activity to learn about redox reactions in detail. Example of redox reactions. Click each tab to learn more. Take 1 gram of copper powder in brown color in a china dish. Place the dish on a tripod stand with wire gauze. Heat the copper powder using a Bunsen burner. The color of the copper powder turns black from brown. Here the solid copper powder burns in the presence of oxygen gas in air. The product formed is the black copper oxide. The reactant copper gained oxygen in this reaction. Hence it is oxidation. Take the black copper oxide in a glass tube supported by 2 strands on its both ends. Put corks with a nozzle in them on the 2 ends. Pass hydrogen gas from the nozzle of the first cork and allow the gas to leave from the nozzle of the cork on the other hand. Use a Bunsen burner to heat the black copper oxide powder in the presence of hydrogen gas. The black color of the copper oxide powder changes to brown. Copper oxide gains hydrogen or loses oxygen and turns into copper again. Hence, it is a reduction reaction. In this reaction, copper oxide is said to be reduced and hydrogen is oxidized. Together, the oxidation and reduction reactions form redox reactions. Now, let us learn about some examples of oxidation reaction from our daily life. Oxidation is the process of interaction of oxygen molecules with anything they come in contact. Some of the examples of oxidation from our daily life are browning of cut surfaces of fruits, formation of metal oxide on metals like iron rust, burning of crackers. Formation of black coating on silver items. Formation of green coating on copper items. Formation of metal oxide on the service wire during rainy season. The spoiling of food materials due to oxidation is called rancidity. Food materials containing oil or fat in them smell or taste foul when left uncovered for a long time. Corrosion or oxidation of metals can be prevented by protecting the metal surfaces from moisture and oxygen. Oiling, greasing, painting, galvanizing and chrome plating, and by alloying. Galvanizing is the process of coating the surfaces of iron with zinc and provide protecting from corrosion. Alloying is mixing two or more metals, a metal and a non-metal, to obtain the desired properties like strength, hardness and lightness from the obtained substance. Rancidity can be prevented by adding preservatives like vitamin C and vitamin E, adding oxidants and keeping the food in airtight containers. Improve your learning. Read the questions and attempt the answers on your own. You can click answer for your reference. Drawing skills. The drawing section helps you to sketch images in a step-by-step manner. Click each tab to know more. Follow-up work. Take up the following activities. Double exchange of the places in the reactants forms double displacement reaction. Rancidity can be prevented by adding preservatives like vitamin C and vitamin E, adding oxidants and keeping the food in airtight containers. You have successfully completed the chapter Chemical Reactions and Equations.